Hey guys, welcome to section 3.A. Sorry for the weird numerology, it's just I'm not really following your textbook, so deal with it. This is matrices and basic operations that we're going to do with the matrices. The essential question is, what is a matrix and what are some of their uses? And English teachers would be very mad that I said what is a matrix but then used there. It's like not matching pronouns. Anyway, you don't care about that. All right, whenever I think of the word matrix in math, I think of this really cool movie called The Matrix. And it's sort of disappointing because as cool as the movie is, in the math world, most people just kind of hate matrices. And they hate them for a variety of reasons. They hate them because they don't know what they do. There's some complicated operations with them. I think the biggest thing is that they take up a lot of paper. So even though I always think about the movie, the reality is much less cool. Anyway, I'm hoping today to explain matrices in a way that will make them make sense. They're actually incredibly useful for the real world, like especially in businesses. For those of you that want to go into computer programming, there's a ton of matrices in computer programming. So knowing what these things actually are and what they do is probably one of the most useful things we'll learn this year as far as real life applications. And that is because all a matrix is it is a way to store information. So let's say you're a sandwich maker. Here are the sandwiches that you make. You opened up a restaurant, here's your menu. You have your regular sandwich, 2 slices of turkey, 1 slice of cheese, 1 slice of tomato. You have your double protein for those guys that just came back from the gym and you can read what the slices are. And then you have vegetarian for people that don't want turkey. Anyway, the point is, if I were the shop owner of this sandwich making shop, I could put all of this information into a matrix. Now, you know that matrices typically look like kind of like this in math. They have these little brackets on the side. I'm gonna make like 3 rows. This top row is gonna be for the regular sandwich. This the middle row is for the double protein. And then the bottom one will be the vegetarian, or veg for short. And I'll make the columns kind of how many slices of each ingredient there should be. So I'll make the first column turkey, the second column cheese, and the third column tom, which stands for tomatoes. And I can store all the information that I need about the sandwiches in this matrix. So for example, for the regular sandwich, I know that there are 2 slices of turkey, 1 slice of cheese, 1 slice of tomato. For double protein, there was 4 turkey, 2 cheeses, 1 tomato, and then for the vegetarian, I guess there was no turkey, so 0, and then 2 cheese and 2 tomato. So putting this in a matrix just allows me to see, hey, here's all of the information all in one condensed mathematical format. And if I was computer programming, or if I was putting this into say Excel or something like that, I could program these numbers in and then I could do stuff with them. Before I show you what you can do, we just need to talk about a couple terminologies. Each one of these entries is called an entry. So this is an entry, all right? It's just the little individual piece of data. And then we call the dimensions of this matrix, the dimensions. We're going to name it rows by columns. And I'll tell you what I mean by that. We have 3 rows, so this is a 3 by. We have 3 columns. So this is a 3 by 3 matrix. This is the matrix dimension. This is the matrix size. We'll be talking about matrix dimensions a lot. It's a 3 by 3, 3 rows, 3 columns. We'll be talking about why that matters later on. So first of all, let's just look at what we can do with this matrix now that we've made it. So say I have a party option, because what's better at a party than just a whole bunch of sandwiches? And the party option is I'm making 20 of each sandwich. And I want to know how many of each ingredient is now needed for the sandwiches. Now, you can probably very easily think about this on your own. Okay, for the regular sandwich, if I have 20 of them, wouldn't I just multiply this 2 slices of turkey times 20? And wouldn't I just multiply this 1 piece of cheese times 20? And when I just multiply this 1 tomato times 20, because I'm making 20 sandwiches, right? And that's exactly how what is called scalar multiplication with matrices works. So scalar multiplication is this. You're literally just taking your matrix and you're multiplying it by a scalar. This thing is called a scalar. And what I'm doing is I'm just going to multiply every single entry in the matrix by this scalar. It kind of, you can think of it as distributing through. So scalar multiplication, I'm just multiplying every single entry in the matrix by the scalar. So my new matrix is, let's see, 2 times 20 is 40, 1 times 20 is 20, 1 times 20 is 20. Do you see what I'm doing here? 4 times 20 is 80, 2 times 20 is 40, and so forth. So let's fill in the rest. 40 and 40. Okay, so this new matrix, what does it tell me? What's this new matrix telling me? This is telling me for the party option, how many slices of turkey will I need for the regular sandwich? Like all the rows and columns are still the same. This matrix just tells me what do I need for the party option, how many of each thing. And you see why this is sort of useful. Instead of doing every single one of these entries, let's say you were putting this into a computer. Instead of doing every single one of these entries individually by hand like we just did, you would be able to just program this matrix into your computer or your calculator, just hit times 20, and because of the way this is working, the calculator will automatically spit out this for you. So again, matrices, think of them as a way to store information so that it can be quickly manipulated. There's something else we can do with matrices. So let's just think of a scenario. Sales are low. You need to revise the ingredients of your sandwich. You got to boost the business somehow. So you decide to make the following changes to each sandwich. For the regular sandwich, you're going to add 1 of each ingredient. For the double protein, you're going to add 2 turkey slices, 1 cheese slice, and you're going to take away the 1 tomato slices because those gym guys, they don't need their tomatoes, they just need their protein. For the vegetarian, you're going to take away 1 cheese slice and add 2 tomato slices. Okay, so the point is, you could very easily look at this information and just say, okay, based on the regular, I'm adding 1 of each ingredient, so instead of 2, now it's 3, instead of 1, now it's 2, instead of 1, now it's 2. But again, let's think about how this would work if we don't want to kind of do everything by hand. Let's see how this would work if I'm maybe programming this into a computer. Let's add another matrix to this matrix. So take a look at what I'm doing here. This is the original matrix, right? This is what the sandwiches originally are. This new matrix, which still has all of the same rows and columns, like here's the turkey column, here's the cheese column, this first row is the regular row, this last row is the vegetarian row. Let's call this the change matrix, because this matrix is going to reflect all of the changes that are happening. So if for the regular I'm adding 1 of each ingredient, think about what that would look like in the change matrix. My change is +1 turkey, +1 cheese, +1 tomato. For the double protein, they're saying add 2 turkey slices, so +2 turkeys, +1 cheese, and they're taking away 1 tomato slice, so that would be like -1 tomatoes. And then for the vegetarian, let's see, they're not doing anything to the turkey. They're taking away 1 cheese slice, so -1, and they're adding 2 tomato slices, so +2. So basically, I'm just recording in this new matrix, hey, here are all the changes that are happening, okay? When we add these matrices together, do it like you feel like it should be doing. Didn't we say that this 2 should become 3 because I'm adding 1 of each ingredient? And that's exactly how matrix addition works. I'm going to take this 2 plus this 1, and in my new matrix, this is kind of representing what the new ingredients are. I have 3. Again, I started with 1, I'm adding 1, now I have 2. I started with 1, I'm adding 1, now I have 2. See what I'm doing here? I'm just taking the corresponding entries and adding them together. 4 and 2 is 6. 2 and 1 is 3. 1 plus -1, well that's 0. And so forth. 0 plus 0 is 0, 2 plus -1 is 1, 2 plus 2 is 4. Nice. And so this is the new matrix. And if I was looking at this new matrix, I'd be able to tell instantly how many cheese slices on the double protein. Okay, well, here's the cheese column. Here's the 2 times protein row, 3. It's all stored there right for me. Did we need to make this new matrix and do it? No, but again, think about if you're storing large amounts of information, this would be a good way to do it. So to add matrices, just add corresponding entries. Something that doesn't make sense is adding a matrix to this matrix that just doesn't really correspond. So for example, we said that this was a 3 by 3 matrix. Let's say I'm adding a 2 by 2 matrix to it. So that's 2 rows and 2 columns. Maybe it's 1, 0, 3, negative 5. Does it make sense to add this matrix to this matrix? Well, no, it doesn't. There aren't corresponding entries. Like, what does this negative 5 match up with? Does it match up with this one? Or since it's kind of in the second row and second column, does it match up with this one? The point is a big fat question mark. I don't know. These matrices, this guy and this guy, they clearly don't refer to the same thing because they're not the same size. Like, what are the columns here? Is this turkey and this cheese? Where's the tomato column? Do you see what I'm getting at here? This matrix is clearly storing a different set of information than this matrix. So when you're adding matrices, you have to make sure the matrices are the same size. All right, so just a quick summary. Remember, matrices, they are a way to store information. They're used a ton in computer programming and whatnot to store information. With scalar multiplication, you simply distribute. Multiply each entry in the matrix by whatever the scalar is, by whatever I'm multiplying by. For matrix addition and subtraction, though, you're going to add or subtract corresponding entries. Just make sure the matrices must be the same size. So guys, I hope this video made matrices a little less scary to you, and I hope they made matrices seem like, okay, these are actually going to be pretty useful in the real world if I'm storing a large amount of data. Thanks for watching. See you in class tomorrow.